Ever wonder what your body's doing after you've, had a really good meal? Like, how does it actually handle all that fuel?
Oh, it's a fascinating process.
Well, today we're taking a deep dive into what's called the well-fed state. Basically, it's how our metabolism works when we're well-fed.
Makes sense.
We're basing this deep dive on this YouTube video, Metabolism in the Well-Fed State, from the channel Metabolism Made Easy. I picked this one out specifically for you, actually, because I know you're really interested in how your body uses the food you eat, and this video breaks it all down.
Oh, cool.
So, like, after a meal, we all know we've got carbs, proteins, fats being digested, but what actually happens to all that stuff?
Well, the first thing is your blood glucose levels start to rise. Think of it like sending up a signal flare.
Okay,
And that flare tells your pancreas to release insulin.
right, insulin. That's pretty important when it comes to metabolism, isn't it?
It is. It's basically like a master key.
A master key.
Yeah, it unlocks muscle and fat cells so they can absorb the glucose from your blood. Without insulin, the glucose wouldn't be able to get where it needs to go.
Interesting. Now, the video mentioned the liver and muscles specifically. What's going on with them?
Well, the liver, you can think of it like the central processing unit of your body.
Okay.
It filters toxins, stores vitamins, does a lot. But in the well-fed state, insulin tells it to start storing glucose as glycogen.
Like stocking up.
Exactly, like packing away leftovers for later.
Smart. So some energy gets stored, but we need energy to use right now too, don't we?
Absolutely, and that's where glycolysis comes in.
Glycolysis.
Think of glucose as a big log of wood. Glycolysis is like chopping that wood into smaller pieces, releasing energy your cells can use.
Makes sense.
Insulin kicks this process into gear in the liver and muscles, making sure you've got readily available fuel.
It's amazing the way the body does all this. Now, the video also mentioned fat tissue, and it used these terms, triacylglycerol synthesis and lipolysis. Those sounds a little complicated.
I know, right? But they're just fancy names for fat storage and fat breakdown.
Okay, so break it down for us.
So triacylglycerol synthesis, that's basically your body converting excess glucose into fat and storing it in your fat cells. Insulin's the one giving the orders here.
So insulin's basically saying, hey, store this energy for later.
Exactly. And at the same time, it actually puts the brakes on lipolysis, the breakdown of fat, by inhibiting an enzyme called hormosensitive lipase.
An enzyme?
Yeah, this enzyme acts like a gatekeeper, controlling the release of stored fat. Insulin keeps that gate shut when you're in the well-fed state.
So it's all about conserving energy after you've eaten. What about the brain, though? It needs energy all the time, right?
It does. The brain is a real energy hog, and it runs almost entirely on glucose.
Really?
And here's the thing, it can completely oxidize glucose.
Oxidize.
Basically, it extracts all the energy it can. We're talking 38 ATP molecules per glucose molecule.
38. That's a lot. Why does it need so much energy?
Well, think about it. The brain controls everything you do. Thinking, feeling, breathing, your heartbeat, everything. It's always working. All those complex processes need a ton of energy.
Makes sense. So before we finish up, let's do a quick review. What are the main takeaways here?
Sure. Basically, when you're in the well-fed state, your body focuses on managing all the nutrients from your meal. Glucose levels rise, insulin's released, and it acts like an orchestra conductor.
Okay.
It coordinates energy storage and usage throughout the body. The liver stores glucose as glycogen, breaks it down for immediate energy. Muscles take up glucose for fuel and storage. Fat cells store excess energy as fat. And all the while, the brain's happily munching on glucose, powering everything you do.
It really is incredible how all these systems work together. It kind of makes you wonder, if our bodies are so efficient at storing energy, what does that mean for, like, how we think about weight management?
That's a good question.
Definitely something to think about.